Alright guys, welcome to this page of the notes, and what we're now going to do is use the law of sines that we just looked at on the previous page, and we're going to use that law of sines to help us solve for some unknown lengths or angle measures here in the triangles that I have given you. And so here we go, let's jump right into this. So first I need to know, do I have enough information to prove or to use the law of sines? So let's take a look at what I've been given. Looking at it here, I have an angle, and a side. So I have angle, angle, side. Was that one of the cases where the law of sines appears? Again, if you go back to the previous page, the angle, angle, side, actually it is. That was one of our cases, so I do have enough information to go ahead and use the law of sines. Angle, angle, side works for the law of sines. So now all we got to do is set it up. So here's what I've got. Please notice that I've been given the angle R, and I've been given the opposite side of R. So I can set up the sine of angle R over its opposite side, right? Remember, that's the way the law of sines works. It's the sine of the angle divided by its opposite side. Now that has to be equal to something. So let's see what else I've been given. Well, please notice that I've also been given angle S. So I will have the sine of angle S divided by its opposite side. Since this is angle S, this is its opposite side. Well, now you're all set. You have now set up the law of sines, plug in what you know, and we solve for the one thing that we don't. So, sine of R is 35. Sine of 35 degrees divided by 15 is equal to the sine of 38 degrees divided by S. Okay, well now what we need to do is we need to solve for S. Sorry, my S probably looks like a 5 and I don't want to confuse you. We are definitely solving for S. Okay, so here's the way this is going to work. What you're going to do is simply cross multiply, right? I'll multiply the S over to this side, multiply the 15 over to this side. I wind up with S times sine of 35 degrees is equal to 15 times the sine of 38 degrees. Again, this goes back to what we did in a previous chapter when we were solving the ratios or proportions of similar triangles, right? This is nothing more than just a proportion, right? And so we are solving this proportion for our unknown value, which in this case is S. Well, since I have multiplication here and I need to get the S by itself, we'll divide the sine of 35 degrees over to the other side, and we wind up with S is equal to 15 times the sine of 38 degrees divided by the sine of 35 degrees. At this point, guys, it becomes a calculator problem. Don't fat finger something on your calculator. You'll do the sine of 38 degrees. That's a number. Multiply it by 15. Then divide by sine of 35. If you do that, you're going to wind up with 16.1. 16.1. So what did we just find? We just found the length of side S. Right? Let's do another one. All right, here we go. First, do I have enough information to use the law of sines? Well, let's take a look and see what I was given. It looks like I was given angle, so I was given angle, angle, side again. So this will be angle, angle, side, and just like in the previous example, angle, angle, side is enough information. That is one of the conditions that will allow me to use the law of sines. So here we go. Let's set it up. Once again, I was given angle R, and I know its opposite side. So sine of R over R is equal to, what's the other one I'm given? Well, once again, I'm given angle S, and that will be over S. So we'll have the sine of S over side S, and now it's plug and chug. We'll do a little bit of algebra, and then our calculator will do the rest. Sine 33 degrees over 18 is equal to the sine of 35 degrees over, I don't know, right? We're going to solve for S. That's a weird looking S. Let me fix it. Okay, great. Well, we already did this algebra up in the previous one, right? Remember the way it works. You cross multiply, so the 18 will get multiplied this side, then s gets multiplied this side. But to get the s by itself, I'll have to divide by sine of 33. So I think we can do that all in one step. You'll wind up with s is equal to, remember the 18 gets multiplied to this side, so that'll be 18 times the sine of 35 degrees. And then that all gets divided by, right, when I multiply the s to this side, I'll have to divide sine of 33 to get the s by itself. So we'll divide by sine of 33 degrees. Once again, at this point, now that you've set up your ratio, right, or set up your proportion, we've solved for our unknown. It's a calculator problem. Sine of 35, hit enter, multiply by 18, then divide by sine of 33. Again, every calculator has a sine, cosine, and a tangent button on it. In this case, you're just using the sine button. Anyway, you put that in your calculator, don't fat finger something, and you wind up with s is equal to 19. And so now we were able to find, once again, able to find side S. All right, let's do one that's a little bit different this time. Let's take a look at this problem. Here's what we've got. First, take a look at what you've been given. I've been given a side, and an angle. That's side, side angle. Okay, now, is side, side angle enough information to use the law of sines? The answer is yes. Yes, it is. It is one of our conditions for being able to use the law of sines, but this is the one that I pointed out on the previous page, is the ambiguous case. Now, we'll talk more about the ambiguous case in just a second. For right now, what we're going to do is we'll go ahead and set up the law of sines and see if we can solve for what we don't know. So here we go. Let's see, what angle do I know? I know angle B, and I know its opposite side. So I'm going to do the sine of B divided by B has to be equal to, now please take a look at what I know. I do not know another angle. I don't know angle A or angle C. So then what we got to do is take a look at what I do know. I do know this guy right here, this side is 15, and it is across from angle C. So angle C, or the sine of angle C, divided by, C. Okay, so now I've set up the law of sines using the information I've been given. In this case, we will not be solving for a side. I already know both of the sides. In this case, we're going to be solving for an angle. We're going to be solving for angle C. That's the information I didn't have when setting up this proportion. So let's take a look at how this is going to go. First, plug in what you know. Sine of 33 degrees divided by 12 is equal to sine of angle C. I don't know what that is. That's all divided by 15. Okay, great. Well, I got to get sine of angle C by itself. So that means multiply the 15 to the other side. So we'll have the sine of angle C is equal to 15 times the sine of 33 degrees. Right, when I multiply the 15 to the other side, it gets multiplied into the numerator, and then I have division by 12. So this whole thing will be divided by 12. Now, this goes back again to the previous chapter. Please keep in mind, I'm trying to solve for the angle. What is the measure of the angle? I need to get this C, right? I'm trying to solve for C, the measure of the angle C. What is the measure of this angle right here? In order to do that, I'm going to have to take the inverse sine of this side, right? Take the inverse sine of this ratio in order to find that angle C. We did this back in the previous chapter. You should be familiar with taking an inverse. So I know that the inverse sine of all this stuff, 15 sine of 33 divided by 12, that's going to give me the measure of this angle, right? To solve for the angle, I have to take the inverse sine. Okay, this is a lot to put into a calculator, so we're going to do it bit by bit. First, you're going to take the sine of 33 degrees. You'll multiply that by 15, then divide by 12. Once you get this number, you'll do the inverse sine. Again, your inverse sine function should be the exact same button as the sine, except you'll have to hit this second button because it'll be in a different color. So whether it's blue or yellow or whatever it is, just hit that second function button, then hit the sine button. It'll give you the inverse sine. You'll take the inverse sine of whatever this number came out to be. As long as you do that correctly, don't fat finger anything on your calculator, you should wind up getting 43 degrees. You may have to round a little bit to get to the nearest degree. I don't think it comes out to be exactly 43, but if you round to the nearest degree, you'll get 43 degrees, which would be the angle of C. That is the measure of angle C. All right, guys, that's the way the law of sines works. First, we're going to check to make sure that the information you're given is enough to actually apply the law of sines. Then, once you know the law of sines will work based on the information that you were given, you'll set up your law of sines, plug in what you know, and solve for the piece you don't. Whether you're solving for a side or solving for an angle, it's all stuff that we've done in previous chapters, going back to sine function and inverse sine function, as well as solving these proportions by doing cross multiplication. So again, we're just using a lot of algebra, geometry that we've already looked at, and now applying it to triangles that don't have a right angle. These are non-right angle triangles, and the law of sines is still going to allow us to solve for unknowns. Head on over to the next page of the notes. We'll take a look at the ambiguous case and how it makes things a little bit trickier. I'll meet you there.